Okay. Um, okay, so welcome once again. I'm recording this for the benefit of those who are here and also those who are on the way. Okay. Today we'll have this tutorial. It's more like a revision. It's not tutorial. So later I will pass all the informations for you some tips. Okay, so I think my connection here is not so okay. It's okay. So your midterm will cover 10% of your marks, and it will have two questions. So question one and question two. So maybe question one will have a few parts A, B, C, D like that, and question two will have A, B, C, D. Uh, so later I will pass you all the the details of midterm. So maybe tomorrow or day after. Okay, once I'm back to Perlis. Okay, I'm still in KL. So I also met some of your friends yesterday in PICC, Putrajaya Convention Center. So even I do face-to-face class, so it won't be beneficial for many because many will not be there. And we also recently received a, a instruction since all the universities are involved with the Festival of Idea in Putrajaya, so we cannot conduct physical class or conduct tests. So I don't know how many tests were postponed or classes were postponed, but so I think Google Meet will still give advantage for us because we can record, so we all can listen again and again. Okay, for you all to do prepare yourself. So I believe most of the tests will be after midterm break, and you all also need to study more, okay, various subjects. I totally understand. So that's why I will be giving some topics. Okay, so you only focus on that topics, subtopics. So you no need to focus on the other subtopics. So I will give that, but I won't give the exact question. So I think those my previous student you all know. So I won't give the exact question, but I will just focus and give you the subtopics that you all need to focus. Okay, so that one I can do. So maybe I will give tomorrow, probably by tomorrow. Okay, so for today, so I'll be discussing. So if you all have any questions regarding the first five chapters, you all may ask. Okay, you all may ask so that I can just review whatever things. Okay, maybe I will just go through chapter 1 until chapter 5 first, all the slides. And in between, if you all have questions, so please jot down and we will discuss at the end of uh, the revision session. Okay, so before I start, so any questions?
Doctor,
Yeah,
sorry, just one question. For
yeah,
chapter 5, Doctor already upload the slide or not?
yeah. I haven't upload. I will upload. Actually, the slide is available and the YouTube video is available. But once I give that puzzle, I wanted to put in the Google Classroom, but I doesn't part lah. So actually, I overlooked it. Then when I was driving back, then I remember I haven't give you all. But I will give after the class. I will put in the Google Classroom for your use.
All right, thank you, Doctor.
Okay. Okay. So I think so far all the materials are available in Google Classroom. all the class recording, all the head puzzle recording, assignment, everything are there. Okay, so next week I will start to take attendance based on the head puzzle assignment. So because all the while we were only focusing on ed puzzle assignment, we didn't do physical class or synchronous class. So I think we only managed to meet you all for the course introduction, and then after that, so we are meeting only today. Okay, so please complete your ed puzzle assignment. So I see many still haven't answered because I can see the progress there. How many percentage of video you have listened. So I believe all the videos are not long. So mostly like I think the most will be 40 minutes, 38 minutes, so like that. So try to settle maybe one or two videos daily. So I think by the time I take the attendance, so most probably I will take the attendance next week Friday. So you have another 1 week to complete. So if you haven't complete, please complete because for your final exam, because once you complete your midterm test, so we will have meeting. The lecturers will have meeting, and we need to update the attendance. So if your attendance are not good, then I need to put in the report. Okay, so this student, this RPS, so they didn't attend this class, so didn't attend the class. So I don't want later on they bar you from taking final exam because your attendance must be at least 80%. So 80% is inclusive of lectures, tutorials, and also your lab. So please attendance. Please uh, focus on your attendance also. Okay, so I think the class I already gave flexibility. So you have like a certain time for you to listen, and the videos are not long. So please complete it within the time given. Uh, so don't do last minute because if last minute, so more videos are coming in, then you will become stressed. Why so many videos I need to listen? So don't have you don't need to have that kind of things lah. Okay. So for first five chapters, I have covered my part. So after this, Prof one will take over. Okay, chapter 6 until chapter 10. So I don't know how he going to execute. I don't know it will be online or you want to meet face to face. So I'm not sure. Okay, so later Prof One will contact you all after maybe possibly after the midterm, midterm break. So then you will take over with the class. So you will be covering another five chapters, and we have four more labs to go. Okay, so I think labs uh, similar like how we execute lab one. Each lab will have two lab modules. One is part one and part two. So part one, I will give 1 week early. So you need to complete. So it's actually to save some time because usually what we will do for the lab, we will go to the lab. Then the lab instructor will teach some theory. Then only you do experiment. But we need to understand that we have many students. Uh, the total for now we have 165 students, and we need to divide into four labs. So meaning we need to do all the explanation for four times. Uh, so that's why what we do, we try to cut short because if four labs, one lab you will have around 35 students, one lab session. So 35 students, I think you will have almost 40. So if you want to do the experiment, you want to take the reading, so it will take a lot of time. So we want to cut short. the explanation part. So that's why we give 1 week the part one. So you complete. You take one. I think the questions in part one is very basic. Just draw the symbol, draw a sample circle. So you can just go to Google. You can do some research, find out something, or refer to the book. So just draw, and when you submit on time, you will get extra marks. So if you didn't submit, you will not get extra marks. Then when you go to lab, so you already know some basics about what you're going to do. So at least like 50% of the thing you already do revision. Uh, so if you copy your friend, I cannot say anything. Of course, you go there with zero understanding about what you're going to do. So once you go to the lab, so immediately we will start data collection. So we will conduct experiment based on groups. So you will run the experiment. So last week you suppose you already finished the part two for lab one, but one Aimi is not well. She was admitted to hospital. So she apologized. I also apologize because I cannot. This week supposed to be lab part two, lab one part two. But I also not around, so I cannot like cover for her. But she already did all the experiments last week, prepare for this week. So unfortunately, so medical reason can happen anytime. So please forgive her lah. Forgive her. So uh, what we will do once we go back. So maybe the first week, week number 9. So you all will be having a lot of midterm tests. So that week we will not have lab. So we will start week 10 onwards. So every week we will have lab. Okay, so that's on the execution part. So lectures and tutorials. For my part, I only have assignment one. I already gave assignment one, so you can submit by 16th of December. So 5 p.m. So you can submit to my office. So I will place a box outside or maybe inside. So you just come and submit. Uh, so quiz will be covered by Prof One, and you also will give you one assignment. So midterm on me. So I will be we will do on 10th of December. Okay, so this is the execution plan. So the latest one that I want to update you all. Um, so I hope you all are aware lah, whatever is happening. Okay, so any questions? So it's just like an introduction for whatever I want to say. So any questions regarding your midterm or assignment? So if you have, please ask. So don't personal message me. Then I need to explain to everyone again. So if 10% asking the same question, so I think it's not good lah because I need to repeat 10 times. So if you have any questions, please ask now so that I can give first-hand information on what you should do. Okay. So any questions so far? Your lectures at puzzle, um, your assignment, lab one, part one, part two. No, no questions. Uh, I cannot hear you. No, you can hear someone talking. Siapa yang bercakap? Say, and you, I think I heard someone was asking something. So anything regarding the components, the class. Okay, no. Okay, so I'll just go through all the chapters. Okay, salam. Okay, format rujukan untuk assignment. Okay, so for assignment, so maybe I just show you. Huh? Okay, so yeah. Okay, so this is your assignment. So assignment one. Okay. So assignment one. So the submission deadline is 16 December, 5 p.m. So instruction is written here must be handwritten. So it's not even 5 page or 10 page handwritten. So at least I can prevent you from copy a bit, maybe not fully. So we don't want you to copy and paste something not relevant, something that you yourself don't understand, and you just copy and paste. I don't want. Okay, so if you still send a type assignment, then I won't mark. Okay, so I tell before and okay. So you are free to use tools. Okay, so ChatGPT is a great tool, but don't totally rely on it. Okay, so you can get some ideas to answer because all these questions are a bit like real life questions. Some are technical questions, so you can use ChatGPT. Even I use ChatGPT. So ChatGPT is a great tool, but I don't want you all to just simply copy the answer and paste without you knowing because when I read your answer, I know whether it's coming from ChatGPT or something else. So when I can send something uh, that is not genuine, then I won't give marks. Okay. So you are responsible for the answer you give. So make sure you understand things. So why we give assignment? Because assignments are preparing you to answer your final. So maybe the questions are not directly like this, but it can be something related to this. So try to get more information to answer these questions. You can use ChatGPT, but uh, you, you give something which is logical. So when you want to propose, you propose something that is sensible. Okay. So the marks are given based on maturity and technicality of the answers. Okay. So third instruction: add citation and reference. So where you cite the info, don't say don't cite ChatGPT. ChatGPT is not something reliable. So citation must be like a journal paper. So maybe you can get some input from ChatGPT, but ChatGPT also taking from something somewhere else. So try to give a citation and reference. Okay, so citation format. There are many citation formats. So you can use APA format. You can use IEEE format. Uh, so if you use AP, APA format, make sure throughout your assignment you use APA format. I don't specify any format. So you can use any format which are relevant for engineering lah. So not something for social science. No. So usually for engineering, you can decide whether you want to use IEEE format or APA format. APA 6. So APA 6. So I type in chat box. Okay. So IEEE format or APA 6. So you can use either these two. Okay, and submit the answer in proper format. This format means make sure it look like an assignment. So assignment usually imagine you are giving uh, you are working in a company and you want to your boss asks you to do a report. How you will give the report? So surely the assignments will have a cover page. The cover page, then you have a proper. Uh, so you write it neatly. So make sure everything are there. Okay. So don't just take a full script paper, just scribble something and send. So make sure you send it in a proper format. Okay, so there are three questions given. Uh, so try to answer. So try to answer this base. So 20 marks. So 20 marks at least you need to answer it for 20 marks. So inside here you have a few questions. So try to answer the questions accordingly. So don't miss out anything. Okay, so that's on the assignment. So any questions on the assignment? Any other questions?
Doctor,
Yeah,
got one question regarding for the handwritten part.
yeah.
Is it possible can write in the iPad and then print out?
Right in the iPad. Can, but is more. So what kind of you are writing in the
I writing in the
then
Google
you have to
Notes.
convert it into PDF and print.
Yeah, yeah.
Okay. I think should be okay. So iPad I'm still okay. So but make sure it's handwritten lah. So it's
Yeah,
not
can.
using any specific fonts. Look like handwritten.
Yeah. Thank you, Doctor.
Okay. So I saw some question. How long should be the answer be? Okay. So answer for 20 marks. So I always tell the rule of thumb. 1 mark usually will be 2 lines, the full script paper. But provided your writing is medium size fonts. So if you're like very big fonts, so make sure you write uh, at least for 1 mark 3 lines. So 20 marks. So you can estimate can be easily 40 lines. 40 lines, maybe one answer like one and a half page, 1 page. Uh, so it's like that. Okay. So any other questions or assignment? This assignment is 3 marks out of total, but 3 marks is still big. Still big. Okay. So later, Prof One will give another assignment for you all. Okay. So anything else? Okay. So I think that's all. Uh, Kalau drawing or gambar. Okay. So drawing. So try to draw. So try to draw or sketch. Uh, so try to draw or sketch. So, but if you need to catch a photo and put, then you can just print the photo. But make sure you put the sketch or picture or figure. Make sure you label it. So label it meaning so you need to like mention. So this part is this. This part is this. Uh, so sometimes we also don't know what actually you are drawing. Why you put the thing. So make sure if you put something, you explain in the paragraph. something related to the figure. So you cannot just put a figure and expect me to understand. Uh, okay. Is there anything else? Okay, for your midterm test, so there I told you there are two questions. So I will give you the exam uh, questions as well as the answer sheet. So I will give. So you don't need to bring anything. You just need to bring your stationaries. Okay, stationaries. Then you can just complete your assignment, your test. Okay, once complete the test. Question paper you can take. Answer sheet you just pass to me. Okay, so anything else regarding assignment? So any question regarding the lab? Okay, for this subject, we have four labs. So three labs will be either the physical lab or simulation. So usually I will give a lab module. So you just do it accordingly and submit, then you get mark. So there will be one open-ended lab 4. So open-ended lab, so no lab module. You need to generate the lab module by yourself. But we will assign you into groups, and you need to submit it in groups. Okay, so that will be something that we will give you earlier. Okay, maybe week 10 we will give. So you have like 1 month to complete that open-ended assignment lab. Okay, that will be lab 4. Lab 1, 2, and 3 will be normal labs. Okay, so we will just do. You just need to, and for part 2 of each lab, you need to submit at the end of the lab session. So meaning you take the data, so immediately you complete the lab report and you submit on the spot. They no need to take back. You submit after 1 week. So usually it will be very troublesome, and we also want to start marking because when the assessments are delayed, when we give more time, so at the end it will be too last minute, and we cannot give you all your carry marks on time. Because if you all know the carry marks, so you all know which part to focus, everything. So we try to give the carry marks before the semester and before you all go to your study break. Okay, so anything else regarding all this, all the assessment? Okay, so if no, so I will just discuss a few things regarding your the lectures. Okay, so this is chapter 1. Can you see?
Yeah, Doctor Ken.
Okay, so I just review in a quick glance. I will just glance through. Okay, so chapter 1. Okay, so we have discussed about per unit system. So per unit system simplifies the complex power system by choosing a common set of base parameter. Uh, so it holds some advantages. of the per unit system. So we can see. Okay. So it's actually per unit system is representing a relative value. It's not the actual value, but something that we can refer to. So refer to we call it as a relative value, and it can help us to reduce the complexity of the calculation. And because we know electrical mission, it involves a lot of things, a lot of things that we need to calculate before we design something. So when we use a per unit system, we can have a relative values, and by using the relative value, we can reduce the complexity of the calculation. Okay, so you can see here. Uh, so all are based on PU value. So when the value is 1.05, we know the generator is generating 5% above the rated, rated voltage. And this is an example. So here we know if VC equals to 1 PU, we know that load C has no drop because we give 1, we maintain 1. So here you give 1, it become 1.05. Please hold on. Okay, sorry. Yeah. Okay, okay. So we can see here when you give 1 and it maintain 1, so that shows that there are no drop. And you give 1, it becomes 0.95. We know that there are 5% drop in the voltage or any values. It can be impedance, it can be current. So that is the purpose of PU system. You want to simplify the understanding of the circuit. Okay, so if the question in the test is asking, so what is the function of a PU system? It's actually to simplify and also make people understand uh, by seeing the circuit. Uh, when we use a relative value, it's easier for us to understand compared to having the real values. Okay, so these are the four base values that we always will use. Okay, so we can see in the examples. So what are the how we can use these base values. So usually when it will have a PU value and it will have a base value. Uh, Okay, so as is the power, so Z is the impedance. Okay, so we only need to know at least two out of the four base values. The remaining two base values can be determined based on this kind of relationships. So in the test, If there are any calculation involved with PU system, so we will give these formulas in the appendix. Okay. Um, I think midterm test we won't have this kind of questions, but maybe in final exam later. So for final exam, I will explain later lah. That. Okay, so these are some of the values. So this is for a three-phase system. So three-phase system, you need to use this kind of setting of formulas here to calculate. You just need to replace the values in order to calculate these values. Okay, so this is try it yourself one. So I think I already explained this in the lecture video. So you can refer back to the chapter 1 lecture video. Okay, so you can have a different form. It can be in the angle form, can be in the complex form, or it can be in the so these two are complex form. Okay, so once you know two base value, so you can determine the other two, and from here we can determine the per unit value. Okay, so like this, so you can find this value based on this relationship. Okay, so find this first. So once you find this, so you can find this, then you can calculate this. So I already explained now. So real part, you use the formula given, and the imaginary part, you just divide directly. Okay, so you can try this questions. You can get this explanation for all the examples and in the lecture video. Okay, so I'm not going through now, so you can check the lecture video. Okay, so that's on the first chapter. So second chapter. Okay, chapter 2 is divided into three parts. Okay, we have discussed about phasor and power. Okay, this is the first part. Okay, what is phasor? Phasor is uh, usually a sinusoidal voltage or current. It has two parts. Okay, one is the maximum value, so this part. Okay, and you have a phase angle. This. So voltage has a maximum value V max and an angle. So this is a delta. Okay. Okay, and we also have a root mean square value, or we call it as an effective value. So in the exam, if I say RMS, I use the term RMS value or effective value. So effective value is actually the value where usually the reading will be. So that is what, because usually you in whatever reading that you take, you will have a maximum value. But usually maximum value you will not achieve, only under certain circumstances. So if not, it will be in a very nominal value always. So that is what we call as a effective value. So imagine you have a car. So car, you have a maximum speed. So usually you can see the speedometer. The speedometer. Maybe you will have 160 or 200 or 220, 250. Uh, but usually we will not travel in the maximum speed of 200 or 250. So the usually we will travel at maybe in highway 110 or 120, in the normal road it can be 60, 70, 80. So that is the effective value. So the maximum value is the maximum speed. So if you want to find the root mean square value or the effective value, so you use this formula. Then we also can represent in the Euler identity. So you can have real and imaginary part. So like this. Okay. J is actually square root of -1. Okay, so you can replace it and you can expand it in this form. Okay. So there are two things. So you can represent equation in a polar form or rectangular form. So we can see it here. So you have imaginary axis and also real axis, and from here we can generate. So this is called the phasor diagram. So Euler identity can be used to convert from exponential to rectangular form. So there are various form. So depends how you want it to be. Okay, so these are the relationships. Uh, so for relationship of the values, we straight away we can take this. Okay, if it's related uh, to resistance, we can take this value. So if related to inductance, we can take this formula and this formula. And if it's related to capacitance, we can take this formula and this formula. Okay, so there's another term called instantaneous value. So instantaneous value is the value at that present time. So usually it will be given like this: VT or IT or PT. So depends. So if you have T, so meaning you need to find at maybe 5 second or 10 second. So it will be given in the questions. Okay. So I just discuss whatever important. I'm not discussing everything. Okay. So all these examples are given in the video. Okay. So please go and refer back to all the examples. So if there are any examples that you don't understand, or maybe it's a mistake, or you have question, please ask me. So I will explain in the group for the benefit of everyone. Okay. So all these examples are quite direct, and we put it there for you to understand. Okay. So we give based on the solutions. So maximum value, so we can find directly from here, and depends on the questions. RMS value, we can use this formula. So these formulas are given earlier. Okay. So I think I explained better in the video. Video. So uh, please refer back to the particular lecture videos. Okay. So example two also the same. Then we earlier we saw instantaneous voltage and instantaneous current. So there's a term called instantaneous power. Okay, instantaneous power is instantaneous voltage times instantaneous current, because the formula for power is VI. P equals to VI. Okay, positive value of power means power flow into the device. Negative value means power is released from the device. You need to understand that. Then we have a term called complex power. So complex power is always referred as S. So S complex power S equals to real power. Okay, so real power plus with reactive power. Okay, so that is complex power. Then we have active power. Active power is always the positive part of power. So usually will be above zero. So zero to maximum. So reactive power, it goes negative and positive. Negative I and also positive I. Okay. So this is exam question. The previous time. So it can be like this in the exam. So we'll be giving you a question, simple question, direct question. Then you need to find, okay, peak voltage. What is the peak voltage? So you need to understand where to find. Okay, so you can try it yourself. Okay, so that's on the chapter 2, part 1. Okay, so if you have question, please stop me so we can discuss. If you have any questions, so just interrupt. So it's more like a discussion. Okay, so chapter 2, part 2 is covering electromagnetism. So electromagnetism is a quite important part, okay, of your studies, because most of the devices are using electromagnetism inside. Uh, so we have coil, we have generators, so everything using the electromagnetic principle. Okay, so there are two things called uh, okay. So the first thing is called okay. We always come with this alphabet B, capital B. So we call it as a B field. So it is referring to magnetic flux density. So the density of the magnetic field. So how dense, so how strong is the magnetic field is defined by the B, the alphabet B, B field. And magnetic field intensity H is so how strong. Okay, how strong. So earlier was the density. This is intensity means how forceful it is. So if you, so let's say you have a magnet. So magnet, when you just put it in one place, around the magnet, B field will be created. Okay, so B field will be created. So it will be scattered for a certain area. Okay, which is near to the magnet. But magnetic field intensity H means how strong is the magnetic. So if the magnet is bigger, so the value of B will be bigger. Okay, so value of B will be bigger, H will be bigger. Okay, so you need to understand. And okay, so these are the formula. So B and H. Okay, so BH curve in vacuum. So in vacuum, B is directly proportional to H using this formula. Okay, so if in a material, so earlier we saw on the vacuum, so in the real life, if it's on the material, we need to find the relative permeability of the material. So mu t. So we need to times with that. Okay, so we will when it's involved for material, we use this formula. So when it involves a vacuum, we use this formula. Okay, so what's the difference? So this mu t. So we need to understand that mu t is not constant because it depends on the flux density of material. So iron might have a different uh, relative permeability. Wood will have a different relative permeability. Glass will have a different permeability. Okay, so if you want to find the relationship between B and H, use this formula. So we can see here. So silicon iron, cast steel, cast iron, all are having different values. Here you can check this example in the video. Okay, so Michael Faraday, so is a famous person for because he discovered the electromagnetism. Okay, his law is called Faraday's law of electromagnetic induction. If the flux, so the Faraday's law is the if the flux is linking a loop, a turn varies in function. Voltage is induced between its terminal. So inside the magnetic field, voltage can be induced when you play around with the flux. So the value of the induced voltage is proportional to the rate of change of flux. Uh, so if let's say you have this, if the magnet is cutting the magnetic field inside, so maybe you enter and taking out. So when you enter and taking out, and due to motion, so the flux will be cut. So when the flux is cut, so it will induce a voltage. So Faraday's law established the basic of operation of transformer, generator and alternating current motors. So Faraday's law is very important. Okay, so maybe you can have some interest. You can go and find what is Faraday's law, what is the real application. Okay, because if I give a subtopic, okay, let's say I give a subtopic, Faraday's law. Uh, so it can be anything related to Faraday's law. So when the question coming about Faraday's law, so you need to understand what to answer. So for you, you need to have some information in your head for you to write. So it can be daily life application. So daily life application is operation of transformers. So transformers, because of transformers, we can communicate now because we have electricity. We have a step up transformer, we have step down transformer. So everything inside is electromagnetic. Then we have generators. So generators to generate powers, current, and we have alternating current motors. Okay, alternating current is based on our three phase or single phase current that we are getting in the house. Okay, so this is another example you can check. So voltage and force in conductor. Uh, so when a conductor is cutting the magnetic field, we use this formula. So you need to check and see uh, in the question what kind of thing are given. Is it a point? Is it a conductor? If conductor, you use a different formula. E equals to BLV. Hmm. You can check these examples. Then we have a Lorentz force in the conductor. So what is Lorentz force? It is also called as electromagnetic force. So the magnitude of the force depends on the orientation of the conductor. So it has a orientation. Orientation meaning if it is parallel, uh, so the magnitude of force will be different. If it's not parallel, it is uh, perpendicular, then you can have uh, more force. Okay, so like this. Okay, force is greatest where angle. So the force is like this. If this is perpendicular, uh, so the value is maximum. So when it is parallel, so the current is flowing parallel. So meaning the angle is zero. Okay, so if you want to calculate the maximum force, F equals to BIL. Okay, so please go through all these examples. So I have included many examples inside for you to understand. Okay, direction of force. So this is based on a straight conductor. So when you want to analyze, you need to see the sign in. So whether it's plus or dot. Okay, if plus, so imagine this arrow. So if you are looking from on top, okay, let's say this is the top view. If the conductor is entering, the current is entering inside. Uh, so from behind, you will see behind the arrow. From behind the arrow, let's say you see from behind, you will see this thing like a plus. So that's why. So when you see a plus in your analysis, meaning yeah, the current is entering. Okay, so if the symbol is a dot, so if it's X, current is entering the field. If it's a dot, so you see from behind here, in front here. So imagine the arrow is coming out. So what you can see from uh, when it's coming directly towards you, you only can see one dot. Okay, so that means the current is leaving the field. And you have a residual flux. So you can read this. Okay, so I think I have explained. So that's a term called hysteresis. Hysteresis meaning, so usually it will increase from zero. So once until it reach A. Then let's say you are the current you are reducing is suppose it need to come back like this, but when you suddenly removing it, so it will slowly go down and it will reach here. It won't go back to zero. Usually we expect it start from zero, you it go to let's say value 10, you expect it to come back to zero. But when you have hysteresis, it will end up go to another place. Okay, that is what we call as a hysteresis. Okay, so hysteresis is the memory of the magnetism. It's a process. Residual induction is amount of memory, so it's a magnitude. Okay, how much magnetism is available? Because we know magnet, once you put at one place, even you remove the magnet also, you will experience the magnetic force for some time. Maybe after 1 or 2 days, then the magnetism will slowly leave. Okay, so these are, so you can see hysteresis loop and loss. She's explained here. Okay, then we have eddy current. So eddy current is small current generated due to magnetic flux. So when this magnet, this part is generating magnetic force, a small current will be induced. See, even though all these are not connected, but because of magnetic flux, it will be passed to the other near neighboring conductors. It's some sort like a wireless. Okay, wireless. So it's not connected. It's not having physical contact, but it still can communicate. Okay, so this is eddy current. Okay. Okay, so that is on the chapter 2, part 2. Okay, any question? Chapter 2, part 2. And chapter 2, part 3. So we talk about torque and mechanical work. It's more on physics. Okay, because we are reviewing separately, because when we are involving electrical machine, so it has a calculation part which we covered in part 1. So then we have electromagnetism which is generated inside a machine, that is covered in part 2. And now we are coming to the mechanical part of the machine, because when we want to do machine, the machine must do us work. It either move or it roll. So you can go to industry, you can see so many machines are there, which will do work. If the machine cannot do us work, then no point we keep it. Uh, so it surely will involve a mechanical force, mechanical work. Okay, so first thing you need to understand is force. The force, the formula is F equals ma. Okay, I think you all know this formula. So it's very important formula. Okay, then if it's involve a circle or a turning, so the force will be converted into torque. So how we convert generate the torque? So torque is actually force times with radius. We call it as a torque is actually the turning effect of force. Okay, so you can see these simple examples. Mm, then we have mechanical work done. So it's very important for you to calculate. So mechanical work done is we write it as a capital W equals to FD, force times distance. Okay, like this. You have force, so you pull and you pull it for a distance. So it shows that there's a mechanical work done. Yes, we can see this example. I'm not going through the example. Then we have a power. So power is actually work done over time. The power is the rate. Rate meaning is something to do with time. So rate of salary. Rate of salary means in 1 hour how much you are earning. Uh, so in one day how much you are earning. So rate means is something related to time. So power is actually rate of doing work. So in 1 hour, how much work you have completed. In 10 minutes, how much work you have completed. So that's why it's W over T. Okay, so you can see the examples. I'm not going through. Okay, then we have power of motor. So mechanical power output. Okay, so depends on the rotational speed and also torque. So this is the formula. So this formula is already generated before. So we just use usually. Okay. So efficiency of a machine. So we need to know about the machine. Okay. So one thing we want the machine to do work. Electrical machine. So whether it's drilling or turning. So we have a machine. So we want to ensure that the machine is doing the work properly without causing you any loss. Okay, so if the machine is not efficient, it will use a lot of power. So when you use a lot of power, automatically your electric bill will be high. Uh, so that's why we can see some of the electrical appliances. They have stars, 5 star, 4 star, 3 star. Uh, so if like 2 star or 3 star, usually it will be cheaper compared to 4 star or 5 star. Why? Because the efficiency is low and it will use a lot of electrical power. Uh, so we always our mentality will be, oh, it's okay as long I have aircon, as long I have a fan. So so I already save. So maybe 2 star fan is 100 ringgit. Maybe 5 star fan is 300 ringgit. So we always want to go for cheaper because we think we already save. But actually, compared to the 300 ringgit 5 star fan, so this will take more electricity. End up indirectly you're paying in the electrical bill. So that's why efficiency is very important. How we want to calculate, so we use this formula. Okay, so you also can see some example. So kinetic energy of linear motion. So I think we are familiar with this in our science and also physics. Okay, kinetic energy is involved with movement. So if something is moving, is related to kinetic energy. So the formula for kinetic energy is half mv square. So we can see from here both start at the same level. So here the distance is less, but here the distance is more. So you can see the kinetic energy is this side it is moving more. So the kinetic energy required is more. Okay, so kinetic energy in rotation, we call it as a moment of inertia. So it depends on speed of rotation, mass, and also uh, shape. Okay, so torque, inertia, and change in speed. So it depends on the rate of change of speed. Hmm. So this is moment of inertia. So depends on your size of the material or the arch or the project. So you can determine which material you want to use. Okay, all these are examples. Okay, so that is on the chapter 2, part 2. Any questions? Okay, so chapter 2, part 4, fundamental of heat. Okay, so earlier we have seen the phase, the electrical phase, then we have seen about the electromagnetism inside the machine. Then earlier we have seen the mechanical elements of the machine. There are another thing called it when something is moving and stopping. So there are a lot of frictions involved. So we need to understand that indirectly we will generate more heat. Okay, so heat and temperature is very important in an electrical machine. So uh, this is the formula Q equals to mct. Okay, so the example. Okay, there are three modes of heat transfer. First is by conduction. So conduction. This is famous questions in exam. Okay. So I don't know whether I will ask it in midterm or not. But usually I can see this question in final exam. Okay, the three different type of heat transfer. So you need to understand because maybe you don't remember the text or the explanation, but you need to understand how heat transfer happen. Okay, by conduction means so like this. So you have a bar. So you're only heating up at one place. You can see the temperature is spreading by physical contact. Okay, so the key point of conduction is a physical contact. So the heat is transferred physically by a process called conduction. Okay, so that's one different. Okay. Then we have a heat transfer by convection. So what is convection? Uh, convection is by replacing. This is the concept. So you have a outline. Yeah, I can show how it works. So you have a outline. So what will happen? The air worms become less dense because when it become hot, the air become hot, molecule will be scattered further. So it will become less dense. So after it become less dense, it will started to the molecule will started to lose up and it will go up. So when it go up, the air coils become more dense and coming down back. Because when it become more dense, it is actually when it cool down, it is actually taking temperature inside. So when it become uh, the humidity is increasing, the meaning the water vapor will enter the molecule. It will be coupled up with the molecule, and it will become heavy, and it will start to come down. When come down, it will become a cool air. So the cool air will come to the tree. So similarly, it will have. So you don't have, even though there are physical contact somewhere, but actually this is not really depending on the physical. So we call it as a natural convection. So natural convection meanings it happen in the environment. Then we have a forced convection. Forced convection is accelerated by electrical motor or fan. Here, when you employ a fan, so it will speed up. So that's why when we want to wash our clothes, we hang it out in a windy area. So maybe it can be outside, or at times if raining outside, we will put the clothes in the house and we will on the fan because we want the forced convection to happen. Okay, so natural convection is like this. So there will be losses by convection. So you can calculate based on this formula. Okay, so you can check this example or how to use the formula. Okay, and there are this is the third type of heat transfer based on radiation. So radiation is based on electromagnetic wave. Okay, this is not by physical or not by the wind, but this is based on radiation, radiation or electromagnetic. Okay, so we have a radiation constant. Okay, yeah. So different surface will have a different K value. Okay, so that's on the uh, e transfer. Any question so far? Okay, so I think I will do until chapter 3. Maybe next week, if I have time, you all have time, maybe I will do for chapter 4, chapter 5. Uh, we have 3 more slides to go. So maybe next week I will try to cover or give a ad puzzle assignment, or I think better discuss. And better discuss if you are free. So whoever free can join for us to discuss a little bit, because I only gave you chapter 5 today, so maybe you can go and listen to that puzzle first, get some understanding, some questions. Then maybe next week and before the final midterm exam, so we can discuss on the later chapter 4 and chapter 5. So today I will cover until chapter 3. Then we will close. We have around 5 minutes. Okay, so this is chapter 3. So DC machine, so particularly on the DC motor. So this is the direct current motor, a DC motor. So inside here we can see there are magnets, there are windings, they have a status, They have sensors and so on. Okay. There is something called CEMF, counter electromotive force. Okay. Okay, so you can see here. So when it rotates, because of the okay, so I explain from here. So it has a resistance, it has a magnetic field. So because it is created by the permanent magnet. Okay. So when the switch is connected, large current flows, and the armature is this pipe. It will start to rotate. Uh, so the force will produce a powerful torque. Okay. So the voltage that is induced by the this is the motor. By the motor, we call it as a CEMF. Okay, or we call it as a back EMF because its polarity always acts against the source. So the source here positive, here negative. So it must be positive to negative, then positive to negative. But you can see here positive, here also positive. So that's why we call it as a back EMF. Okay, so the acceleration of the motor is all depends on current and also uh, the voltage. Okay, some examples given here. So the mechanical power and torque. So when we want to select electrical motor or DC motor, we need to understand the power and torque. So how much power? Because certain application requires lesser power. Certain application requires more power. So you need to determine the mechanical power and torque needed from the DC motor. Okay, so you can calculate based on all this formula. Okay, some of the power is because it is receiving input from outside. Some will dissipate. Some will release. Uh, so it will release the power. Okay, in order to lose something. We call it as a heat dissipated. Usually, the dissipated energy will be in the form of heat. Okay, so this is the mechanical power. Okay, all this explanation for the calculation part and also example I have given better in the video, so I don't want to repeat. Okay, so this is example 2. Okay, speed of rotation of the motor. So it must be reasonable speed for uh, reasonable speed in order to rotate the DC motor. If like is lesser or too much, then it will not help us. Okay, so in order for that, so we need to calculate this. Okay, so armature control. Okay, so there's a method called a Watt-Leonard system. What is it? Okay, so I will finish. Don't worry. Okay, sorry. So this is called the uh, Ward Leonard system. Ward Leonard system is using a separately exciting generator to generate another electricity. So we call it as a Ward Leonard system. Okay, the explanation is given here. So we call it as a field excitation. So we use a simple setup to generate. So you don't need to do a lot of modification to the system. Okay, so you can see. So usually, if the question is related to what Linux control system, the question will be like this. Okay, then we have a field speed control. So we want to control the speed by itself. So we connect it into a rheostat. So we call it as a shunt motor. Okay, the setup is called a shunt motor. Okay, then we have a series motor. So the field is connected in series to the system. So you can see the field is like this. So he is connected in series actually. Okay, it's a part. The series field is composed of few turns of wire having a cross section sufficiently large to carry the current. Okay, the example. Then we can have a compound motor. So it's a combination of shunt field and also series. Okay, so it can be if the application need that, it can be called compound means mix, combined motors. Okay, combined mechanism. So we call it as a compound. Okay, so that is the first three chapters, chapter 1, 2, and 3. So maybe next week, if given a time, then we will discuss on chapter 4 and chapter 5. So you all go through first. So after this, I will share with you the lecture note and also the YouTube video for you all to do reference. So next week you have a midterm break. So try to do and also understand. So once we settle, maybe next week Friday evening, so we will meet maybe like 1 hour to discuss chapter 4 and 5. Okay, so those were how about attendance? Attendance for
Today's class.
today I will take. I will give this in a puzzle also. Okay, so I will take. So I have for those who are attending this synchronous class. So the Google Meet will draft me a report, attendance report. So the others can see the video. Right, puzzle. Okay. So any questions before we finish? Sorry, 5 minutes late.